Please
I haven't even.
record the session.
I have not even shared with you the other recordings. Oh no, no one reminded me. Can't you remind me in case I forget? Yes, so Chewa, go ahead, please.
An alloy of steels should be iron and I've forgotten.
Is it iron and carbon?
Yeah, iron and carbon. There can also be a few others like zinc sometimes that are added. But yeah, mainly iron and carbon. All right, then we have what is known as a high-speed steel down here. So high-speed steel is used for as a cutting tool. Okay, it's used for as cutting tools. On the bits, the drill bits and the cutting bits of various material, various equipment that are used, or machinery that are used for cutting metals because of its strength. Okay, because of the strength that steel has. So under non-ferrous, we have pure non-ferrous metals, and then we have the non-ferrous alloys. So under non-ferrous, we have the pure metals and the alloys. So under the non-ferrous metals, so these are just pure metals. We have copper, aluminum, these are the ones that are used in industry mainly. Copper, aluminum, zinc, tin, lead, silver, gold, and mercury. So one interesting thing about mercury is that it's the only non-ferrous metal that is liquid at room temperature. That's why you find it in the thermometers, and those old thermometers that are not even environmentally, they're not environmental friendly anymore. So we're moved away from the mercury thermometers. But anyway, it used to be found in the mercury thermometer, and it was liquid form at room temperature. So coming to non-ferrous alloys, we have brass. Brass is an alloy of what and what? Copper and zinc, please. This is an exam question. Usually this is your favorite exam question. What is an alloy? What is brass made of? So copper and zinc, people usually use this. Bronze is copper and tin. Okay, bronze is copper and tin. Brass is copper and zinc, and solder is lead plus tin. If you need to memorize this, you just have to memorize and you need to know this. So this is just basically the outline that we have for metals, the classification of metals under ferrous and non-ferrous. So this is alloying. As you can see, this is casting. Those that are wondering what casting means, this is casting. This is the metal that is being cast. So when it comes to ferrous metals, like we said, they consist mostly of iron and small amounts of other elements. So one property that we know, significant property that we know about iron is that it's prone to rusting when exposed to moisture. And one other property also that we know is that ferrous metals can also be picked up by magnets. They're quite magnetic. So they have rusting and magnetic properties. So these properties are also found in the alloys also of iron, containing iron rather. So typical ferrous metals include mild steel, cast iron, and steel. So as we go on, you'll know the difference between mild steel, what is meant by mild steel, what is meant by high carbon steel, and so on. You're able to know the difference. So this is an example here of rusting and magnetism. As you can see, the small, tiny metal particles there stuck to the magnets. Okay, so mild steel is a ductile and malleable metal. What does malleable mean? Do we remember?
Malleable, I think it should be malleable. It can be turned into any shape. Yeah.
It can be
made into any shape.
And ductile. You are breaking. Kindly repeat what you just said.
Ductility, it's you are able to bend it
without it breaking, isn't it?
Yes. Then malleable, you can make it into any shape.
Sorry, you're saying?
You can
Malleable.
change the shape of it.
Okay, so ductile is the opposite of brittle. So you can bend, it can bend, isn't it, without breaking? Huh? That's maybe the easiest way to say it. But anyway, you should be able to define ductility in terms of plastic deformation and elastic deformation. Since you already know that material, we already covered it. So you should be able to define ductility in terms of that. But for now, I'll take it, yes. So one a metal that's able to bend without breaking. Then malleable, a metal that can be hit, hammered, and taken into many, that takes up many shapes. So those are the two most important properties of mild steel: ductility and malleability. Mild steel will rust quickly if it is in frequent contact with water. Remember, we're talking about ferrous metals, and we know that with ferrous metals, they contain iron, and iron, the main disadvantage of iron is that it's prone to rusting or corrosion. So when you are dealing with ferrous metals, that one is a likelihood. Rusting is always a likelihood because of the iron content. Except in cases where it's controlled maybe through coating, for example, painting, and so on. So the uses, so looking at mild steel here, it will rust quickly if it is in frequent contact with water. So that's one thing to expect. Then the metal uses, it's used as nuts and bolts and building girders, car bodies, gates, etc. As you can see here, these are the uses of mild steel. It's used with the gates, car bodies, and the bolts and the nuts. So of course, with the car bodies today, if some few years back, all this, what is shown here would be metallic. These days you find that this part will be probably plastic, the end there will be plastic, and the sides will be plastic, and so on. But anyway, these are the major uses of mild steel. It has a melting point of 1,600 degrees Celsius. So we come to cast iron. Cast iron is pure iron, very strong metal when it is in compression, and it is also very brittle. Very brittle. Remember what we looked at when we were looking at compression, when we were looking at stresses. Remember when we looked at stress and we looked at compression, we said that brittle materials are very strong when it comes to compression. Okay. So an example is cast iron. It consists of 93% iron and 4% carbon, plus other elements. So the uses, as you can see just from the pictures here, it's used as car brake discs, car cylinders, metalwork vices, manhole covers, stationary bases, etc. Even as a pillar drill, as you can see here. Also, it has a melting point of 1,200 degrees Celsius. We move on to high carbon steel. So this one is a very strong and very hard steel that has a high resistance to abrasion. So what do we mean by abrasion here? Someone to give it a try. Ferrous, what do you think is meant by abrasion? What does it mean?
Abrasion.
Mm-hmm.
Abrasion property.
Yes, when we say a metal is abrasive, what does it mean? Or is resistant to abrasion?
It can be easily be scraped or wear.
Wear, it can easily be worn out. Yes. So properties are up to 1.5% carbon content, very tough. The uses used for hand tools such as screwdrivers, hammers, chisels, saws, springs, and garden tools, as you can see here. These are pieces of these are tools that are made from high carbon steel. So high carbon steel has a melting point of 1,800 degrees Celsius. So toughness is the main property that you're looking for in this case. You're going to use a tool, when you're going to make a tool, you're going to need to make it from material that is tough so that it doesn't easily break when you start using. Imagine using a screwdriver just to unscrew, for example, a door handle, and then it breaks. So these are the uses. We move on to high-speed steel, HSS. This is a metal containing a high content of tungsten, chromium, and vanadium. So it's an alloy containing tungsten, chromium, and vanadium, aside from iron and carbon. However, it's very brittle and is also very resistant to wear or to abrasion. It's used in drill bits, lathe cutting tools. It's also used where high speeds and high temperatures are created. Melting point is 1,400 degrees Celsius. So you should be able to know the type of steel or the type of metal and just basic use at least. The melting point, not really, but what I'll need you to know is the type of metal and its basic uses, or just its properties. Know that steel is tough, especially for example, high-speed steel, you know that it's very brittle, but also very resistant to wear. Stainless steel, I think this one is the most common that we see around. This one is very resistant to wear and water corrosion and rust. So meaning if you have something written stainless steel, and then it begins to rust, just know that it's not original, it's a fake kind of steel. Properties, it's an alloy of iron with a typical 18% chromium and 8% nickel and 8% magnesium content. So that is what stainless steel is made up of. It's an alloy of iron with a typical 18% chromium, 8% nickel, and 8% magnesium content. So uses, as you can see here, the sinks, sometimes even wristwatches are made of stainless steel. It's used for kitchen sinks, cutlery, teapots, cookware, and surgical instruments. So remember when we're looking at our lecture 1, when we looked at the types of, when we looked at the properties of materials, or we're looking at classification, and we looked at biomaterials and what they should not contain. Remember, we said that if we're going to use biomaterials, for example, if you're going to use metals, a type of metal for a joint, isn't it? Maybe a knee cap or something for a knee joint or a hip replacement. You will not pick something that rusts, isn't it? Because if you picked on cast iron, for example, as a metal for your hip joints, obviously it's going to rust because inside your body there's high moisture content, and iron rusts with high moisture content. Or for example, if you had to replace one of your teeth with a material that is prone to rusting, what will happen to you, Ernest?
Can you repeat that, Doc?
I'm saying if you had to replace your tooth, if you lost a tooth and you had to replace it with a tooth that is made out of a metal that is prone to rust, a ferrous metal, what would happen? Obviously, it would rust, isn't it? Because you drink water, you take fluid, you have saliva in your mouth, meaning you have the mouth has a high moisture content. So if you're going to replace your tooth with an artificial one, then that means the artificial tooth must be made up of material that does not rust. Sure. Is it clear? Ernest?
Yes, Doc. Yes, Doc. Thank you.
Yeah. So it should be made up of material. Sometimes you find that they'll be made out of metals, but these have to be metals that are not prone to rusting. It can be gold or silver, as long as it's not prone to rusting. It cannot be made out of iron or any ferrous metal. Okay, so we come to non-ferrous metals. So these are metals that do not have any iron in them at all. They are not attracted to a magnet and they do not rust in the same way when exposed to moisture. So typical non-ferrous metals include copper, aluminium, tin, and zinc. So different types of metals here. So as you can see, bronze has this color here, some brownish, shiny brownish color. Brass there is on the darker side, less shiny. Tin looks like this. Zinc here. We have our copper here. I think everyone who lives on the copper belt has seen how copper looks like. Lead also is grayish, just like aluminium. So at least you should be able to tell just by looking. You should already be able to have a rough idea when your metal is presented to you. As someone who studied material science, you should be able to tell at least the difference between these things, these metals. So under non-ferrous metals, we have one of the most common non-ferrous metals that we use is aluminium. It's light in color and also weight. And although it can be polished like a mirror, like appearance, it is very light in weight. So it's very light in weight. That's why aluminium is mostly used in aircraft, in in car bodies also, and just generally other places where you need a metal that is tough but light in weight. Light in weight. You need something with high strength but light in terms of weight. So that's where aluminium comes in handy. And that's why in the past century, it was the most favorite or most preferred type of metal when it came to vehicle manufacture and also aircraft because of those properties. It's also found in the kitchen. As you can see there, we have the pots, aluminum pots. It's used for saucepans, cooking poles, window frames, ladders, and expensive bicycles. So some bicycles are made out of aluminum, and of course, they're expensive because aluminum isn't exactly cheap. We also have the frames, the window frames also, they are now trendy. People are buying these aluminum frames, window frames for their houses now. Up to here, do you have any questions? Steven?
Yeah, so far so good. We can proceed.
All right, okay. We come to copper. Copper is ductile and it's also malleable. And the color is often red-brown. And of course, we know that it's a very good conductor of heat and electricity. So where is it used? Plumbing, electric components, cookware, and roof coverings. So maybe a question here, which metal has the highest conductivity of electricity?
Copper, madam.
No. Pardon?
Copper.
No.
Copper.
It's not copper. Everyone thinks it's copper, but it's not.
Aluminium.
Research on that. Research on that. So copper has a melting point of 1084 degrees Celsius. 1084 degrees Celsius. Okay, we move on to zinc. Zinc is very resistant to corrosion from moisture. That's why it's used, to make these pails, these buckets, metallic buckets, and the screws. It's very resistant to corrosion from moisture. However, zinc is a very weak metal and is used mainly for coating steel. So as a metal itself, it's quite weak. So how it's used is mainly just as a coating, okay, for steel. So you have a steel component and then it will be coated with zinc just to ensure that it does not corrode. So what are the uses there? It's used as a coating on steels. I say that steel buckets, etc. And it's also used to galvanize steel. We look at galvanization, we look at galvanizing steel, we look at that when we look at corrosion in detail. It has a low melting point, which is 419 degrees Celsius. So we say it's an alloy of copper and zinc. What is it called? If you still remember.
Brass.
Brass, okay. And then copper and tin?
Bronze.
Bronze, yes. Okay, move forward. We move on to tin. So example, you've been asked, you're one of the engineers that are constructing a ship. Maybe a ship to sail on the Indian Ocean or something, and you've been put up as the materials specialist. What kind of metals are you going to pick for the body of that ship? By ship, I mean SHIP.
I think. Huh? I think you look at the physical properties. Like for aluminum, the weight, since we want it to float, we'll go for the lightweight material, like aluminum. Then you consider zinc also, since it doesn't easily corrode with moisture.
But you have to remember that aluminum is not cheap also. So you have to put in cost into consideration, okay? All right, so yeah, so and then for the screws, the bolts and the nuts.
We go for steel coated with zinc.
Steel coated with zinc. Okay. Good enough. However, you have to also consider one thing when you're talking about the Indian Ocean. There's another, when you look at the environment. So first and foremost, you look at the environment, isn't it? Where that device or that piece of equipment is going to function. So in the case of the Indian Ocean, whatever ocean, the sea or the ocean, for example, that the water there is salty. So meaning it's quite corrosive. So you also have to take that into consideration as you are doing a material selection. All right, so move forward. We come to tin. Very ductile and very malleable metal. It's resistant to corrosion from moisture. It is bright silver in appearance. Okay, so an example here is a tin plate is steel with a tin coating. What we call these tins, right? We call this a tin. Bring that tin here. This is a tin of fish or tin of corned beef. Why it's called a tin really is because it's steel actually. These containers are actually made out of steel, but they just have a tin coating on them. That's why we like to call them tin. So it's used as a coating on food cans, beer cans, those that take alcohol. They use these tins a lot. So it's used as beer cans, it's used as whistles, as tin foil, and also soldering. For soldering, I hope you understand where soldering is used. It's also used for these baking pans also. These are made out of a coating of tin. It has a low melting point, which is 231. Okay. So move forward. We come to lead. What do we know about lead, Kunda, as a metal?
Lead. Yes, Doc.
What do you know about lead as a metal?
As a metal.
Yeah,
it is used in batteries. And another thing about lead is highly toxic.
Highly what?
Toxic.
Toxic, okay.
It's a very toxic metal.
Okay, so it's all right. Okay, all right. So it's a heavy metal, quite dangerous to human health. It's bluish white in color when it's freshly cut, but it soon tarnishes to a dull grayish color when exposed to air. So I'm sure we've heard about Kawe. That's the place where we mine a lot of lead some decades back. So what happens to lead is, in as much as it has its use with the batteries and also it's used for X-ray protection, it's also quite dangerous to human health, in that it slowly accumulates in your body, and it's so bad such that even through your skin, it can actually penetrate through your skin into your blood system. And over time, over years only, will it finally, now when it's just a little amount of it anyway, is enough to even cause cancer and brain tumors and just psychosis of some sort, just not immediately, but over a period of time. So it's best to keep away from it. It's quite dangerous. So we know that Kawe is now considered one of the most polluted cities in the world because of lead exposure. So what is it used for? It's used for roof flashing, for batteries, for X-ray protection, and it's used for its weight in many ways. So there we have. So what do we mean by for its used for its weight? Is it lightweight? Is it heavy? Anyone help us there?
It's actually lightweight.
It's actually lightweight.
It's heavy metal. I think it's the heaviest.
Others are saying it's heavy, others think it's light. So what is it really?
Heavy. So come it's used maybe on tires to balance up the wheels.
Okay. Because it's what? Because it's light or because it's heavy?
It's heavy.
Because it's heavy.
It's actually.
Pardon?
It's heavy. It's actually heavy. It's a heavy.
It's actually heavy.
A small part. You can feel the weight in your. A stone of lead. You can feel the weight as compared to an ordinary stone.
Okay. All right. Yeah, it's quite heavy, but a high density.
Yeah.
Yes. Yes, you're right. That's the other reason why we say batteries are dangerous. Okay, it's because of the presence of lead in them. And that's why also on a plant in industry, when you have your used batteries, you're supposed to have a specific shed where you have those who are doing purchasing and supply. You should know this. You have a specific shed where you store your batteries. Usually it's called a battery shed or something. But your batteries have to be together in one place in a shed, and there are other conditions surrounding it to ensure that you don't have these leaks. Okay, once your batteries begin to leak and this lead begins to leak and leaks into the ground, the soil, it may contaminate. So they have to be in a shade that is concreted and so on and so forth. Melting point is quite low, 327 degrees, so relatively low, 327 degrees Celsius. We come to silver. Soft, white, lustrous transition metal. It has the highest, here's your answer, I asked you to research. It has the highest, here's your answer here, the highest electrical conductivity. So silver actually is the best electrical conductor that we have in the world, okay, that appears in nature. However, it's not commonly used.